Hello students. So this video on the continuation of chapter 2 units and measurements. In the last class we studied about absolute error, relative error and percentage error and combination of errors. In today's class let us study about significant figures and rounding off. Now let us see what you mean by a significant figures. The number of meaningful digits is in a measured or calculated quantity that is called a significant figures. Significant figure is a meaningful digits in a measured or calculated quantity. For example, if we say the period of oscillation of a simple pendulum is 1.62 seconds. Here, the digits 1 and 6 are certain, while the digit 2 is uncertain. Thus, above value has three significant figures. Let us take one more example. The length of an object reported after measurement to be 287.5 centimeter has four significant figures. Here the digits 2, 8, 7 are certain, while the digit 5 is uncertain. Now let us study the rules for determining the number of significant figures. We have to follow the certain rules to find the significant figures. The first rule: any digit that is not 0 is significant. That means all the non-zero digits are significant. For example, 845 centimeter has how many significant figures? 3 significant figures. Here SF, that is significant figure. So 845 centimeter has 3 significant figures. All the non-zero digits are significant. Any digit that is not 0 is significant. That is the first rule for determining the number of significant figures. Second one, the zeros between non-zero digits are significant. All the zeros between two non-zero digits are significant, no matter where the decimal point is. Now here 40,501 kg. Now tell me how many significant figure it is? It has 5 significant figures. So 40,501 kg contains 5 significant figures. The third one, zeros to the left of the first non-zero digits are not significant. The zeros to the left of first non-zero digits are not significant. Here we have the example 0.008 L contains. So here 0.008 L contains how many significant figures? 1 significant figures. Why? The zeros to the left of the first non-zero digits Here non-zero digit is 8. So the zeros to the left of the first non-zero digits are not significant. That is the third rule. For example, we are having the value 0.0023. Now tell me how many significant figure it has? It has a 2 significant figure, isn't it? Now if the number is greater than 1, then all the zeros written to the right of the decimal point is significant. If the number is greater than 1, more than 1, then all the zeros written to the right of the decimal point is significant. Example 2.00 mg milligrams. So here it has how many significant figure? Three significant figures. So the number is greater than 1 and the zeros is also significant. The zero written to the right of the decimal point is also significant. For example, 3.500. 3.500. It has 4 significant figures. So if the number is greater than 1, then all the zeros written to the right of the decimal point is significant. If the number is less than 1, the zeros that are at the end of the number and the zeros that are between the non-zero digits are significant. So here the first case, the number is less than 1. The zeros that are at the end of the number. So here the first case 0.090 kg. This value is less than 1. After the zero that are at the end of the number 9, after the 9 there is a 0. That is also, if the number is less than 1, the zeros that are at the end of the number, they are significant. So here 0.090 kg has 2 significant figures. One more example, the zeros that are between non-zero digits are significant. So here 0.0405. So in between of two non-zero digits, one zero is there, isn't it? So it is 3 significant figures. Now here, if the number is less than 1, the zeros on the right of the decimal point to the left of the first non-zero digits are not significant. Okay. If the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digits are not significant. So here 0.0, that zeros are not significant. They are less than 1 and the zeros of the right of the decimal point but to the left of the first non-zero digits are not significant. That is next rule. And even if the zeros that are between the non-zero digits are significant. Next one, for numbers that do not contain decimal point, the trailing zeros, that is zeros after the last non-zero digit may or may not be significant. 400 can be expressed as 4 into 10 to the power 2. For if we write in this order 4 into 10 to the power 2, then it has one significant figures. Same thing we can write 4.0 into 10 to the power 2. In that case it is two significant figures. So for a number that do not contain decimal points, the trailing zeros, that zeros after the last non-zero digit may or may not be significant. Sometimes it will be significant and sometimes it will not be significant. So that those are the rule for determining the number of significant figures. Now let us see the next one, that is rounding off. So the rounding off, a number is rounded off to the desired number. The number is rounded off to the desired number of significant figures by dropping one or more digit to the right. So here rounding off the uncertain digits, the result of calculation with approximate numbers which contain a more than one uncertain digit should be rounded off. So here we have to, while you are writing in terms of significant figure, we have to drop one number. In that case we have to follow certain rules, that is rounding off rules. Okay, the number is rounded off to the desired number of significant figures by dropping one or more digit to the right. Now rules, rounding off rules: when the first digit dropped is less than 5, the last digit is retained, should remains unchanged. Now here, when the first digit is dropped, so here let us see if the insignificant digit to be dropped is more than 5, and the preceding digit is raised by 1. If the insignificant digit to be dropped is less than 5, the preceding digit is unchanged. Here in the given example, 4.13 can be rounded off to the 4.1 because the ending number, the last number is less than 5, so that the preceding number is unchanged. When it is greater than 5, 1 is added to the last digit, retained. If the number is more than 5, greater than 5, the preceding digit is raised by 1. So here 4.17, 7 is greater than 5, isn't it? It can be rounded off to 4.2. So the previous number is raised by 1. So it will be 4.2. So initially it is 3 significant figure. After rounded off, it becomes 2 significant figures. When it is exactly 5, 1 is added to the last digit, retained. if that digit is odd but remains as it is when it is in even. See, if you are having exactly 5, the last number is exactly 5. In that case, you have to check whether the previous number is odd or even. If it is odd, the previous number is it will be raised by 1. If it is even, it will be remains as it is. See the first example, 4.15. 5 is the exact value, 5. So the previous number is even or odd? Odd. In that case, it is raised by 1. So it is 4.2. The next one, 4.45. Here the previous number is even. So if it is a even, then it should not be, the number will be unchanged. It is not going to rise. So the value is 4.4. Now let us do some exercise of rounding the following numbers. The first one, 423.78 to 3 significant figures. How you will going to write 3 significant figures? You have to round it off. So it becomes 424. The second one, 0.000123 to 2 significant figures. How you are going to write 2 significant figures? So it is 0.00012. 22.550 to 4 significant figures. The value is 22.55. 129.6 to 3 significant figures. So here the ending number is greater than 5. So the preceding number is raised by 1. So the value is 130. 0.365 to 1 significant figures. It becomes 0.4. So the ending number is 6. It is greater than 5. So the preceding number is raised by 1. The last example, 7.206. We have to write 3 significant figures. So here 7.21. So ending number is greater than 5. So the preceding number is raised by 1. Now this is the exercise for a significant figures. You have to, for a given number, you have to write the number of significant figures. The first one, 10,423. How many significant figures? It has 5 significant figures. Second example, 1,230.0. So it has 5 significant figures. Third example, 150. It has 2 significant figures. 0.0032. It has 2 significant figures. 3,300. It has 2 significant figures. 10. It has 3 significant figures. 0.05010. It has 4 significant figures. Try more examples of significant figures as well as rounding off. Thank you, students.